Hey guys, today we're going to do 5-2, polynomials, linear factors, and zeros. Our objectives are to analyze the factored form of a polynomial and to write a polynomial function from its zeros. Finding the zeros of a polynomial function will help you factor the polynomial, graph the function, and solve the related polynomial equation. Problem 1, writing a polynomial in factored form. What is the factored form of x cubed minus 2x squared minus 15x? We first need to take out our GCF, which is leaving us with x squared minus 2x minus 15. Now we can do triangle on our inside quadratic. What multiplies to negative 15 and adds to negative 2? Which is negative 5 and 3. There's nothing that we could divide, so x times x minus 5 times x plus 3 would be our factored form of the polynomial. Roots, zeros, and x-intercepts. The following are equivalent statements about a real number b and a polynomial. So if we have a polynomial function, p of x is equal to our polynomial function. X minus b is a linear factor of the polynomial. So just like we saw in problem 1, sorry about that, x minus 5, x plus 3, those are examples of linear factors of the polynomial. B is a zero of the polynomial function. So the opposite of whatever is inside the parentheses is our zero. B is a root or a solution of the equation. And B is an x-intercept for the graph y is equal to the polynomial function. So finding zeros of a polynomial function. What are the zeros of y is equal to x plus 2 times x minus 1 times x minus 3? Graph the function. So when we were working with quadratics, when we had factored form, we could take each factor, set them equal to 0 to find our zeros. We do the same with polynomials. X plus 2 equals 0, subtract 2 from both sides, x equals negative 2, make a point. X minus 1 equals 0, add 1 to both sides, x is equal to 1, make a point. X minus 3 equals 0. Add 3 to both sides, x equals 3. Make a point. We are going to find values we are going to find points for x values between our zeros to test. So, in between negative 1 and negative 2 and 1, we could pick 0. If we plug in 0, we would get 0 plus 2 times 0 minus 1 times 0 minus 3, which would be 2 times negative 1 times negative 3 is equal to negative 6. I'm sorry, positive 6. 1, 2, 3, 4, 5, 6. The value in between 1 and 3 would be 2. So I would plug in 2. 2 plus 2 is 4. Times 2 minus 1 is 1. Times 2 minus 3 is negative 1. Which means 2 would be equal to negative 4. So we would go over 2, down 4. And we need to determine our end behavior. If we multiplied x times x times x, we would get x to the third. X to the third is positive, odd, therefore it's down, up, and we connect our polynomial. Theorem is, now we're going to be doing the factor theorem. The expression x minus a is a factor of a polynomial if and only if the value a is a zero of the related polynomial function. So if we are given our zeros, we can then use the factor theorem to write them as factors and then write the polynomial in the polynomial function. So if we have zeros x minus 2, 2, and 3, that means after we took our factors and solved, set them equal to 0 and solved, we would get negative 2, 2, and 3, which means we would have x minus negative 2, which is plus 2, x minus 2, and x minus 3. In order to put this in standard form, you would need to multiply it out. What is a quartic polynomial function in the standard form with zeros x minus 2, with zeros negative 2, negative 2, 2, and 3. Therefore, y would be equal to x plus 2, x plus 2, x minus 2, x minus 3. And we would have to FOIL that out. Multiples and zeros affecting a graph. So if a is a zero of multiplicity n, then the polynomial function y is equal to p of x. Then the behavior of the graph at the x-intercept a will be close to a linear if n equals 1, close to a quadratic if n equals 2, close to a cubic if n equals 3, and so on. So it's going to look like whatever the multiplicity is. If we have the function x to the 4th minus 2x cubed minus 8x squared, we want to find the zeros and their multiplicities. So at x to the 4th minus 2x cubed minus 8x squared, I can take out x squared. I would be left with x squared minus 2x minus 8. I could FOIL on the inside, factor on the inside. What multiplies to negative 8 and adds to negative 2 would be x minus 4 times x plus 2. So at x squared, x would be equal to 0, multiplicity of 2, because this 0 occurs twice. X minus 4 would be x equals 4, and we would have a multiplicity of 1. X plus 2 would be x equals negative 2, multiplicity of 1. So at x equals 0, we would bounce because we would look like a quadratic. For x equals 4 and x equals negative 4, we would just go through. We also have what is called a relative minimum and a relative maximum. These would be at the bottom of a hill or the top of the hill. It is when we go from, relative minimum is when we go from decreasing to increasing, and a relative maximum is when we go from increasing to decreasing. If I want to find the relative minimum and maximum, I would graph. We're going to save this one for class tomorrow.